So the centre of gravity, the definition for the centre of gravity, and this definition is usually worth 2 marks in your exam, is the centre of gravity of an object is the point where all the weight appears to act. So the 2 marks come from the point and then where all the weight appears to act. Now, centre of gravity can also be called the centre of mass. The centre of gravity usually indicates where the weight is on an object. As you can see here, when we have a look at this is either a plank of wood or a ruler. This is what we call a uniform object because it's symmetrical. The centre of gravity is marked by the letter P. This is the point where all the weight appears to act on this object. And if you can imagine, as you know, weight is a force, there should be a downwards arrow coming from that point P. Usually for a uniform object like this, the centre of gravity is always in the middle of the object. So when you know that the centre of gravity is in the middle, you know that's where the weight is. So unless stated otherwise, the centre of gravity is always at a uniform object's midpoint. Ignore the reference to moments at the minute, we will look at that later. The centre of gravity of a body may be regarded as the point of balance. If you take a 30 centimetre ruler, it will balance at 15 centimetres because that's where the centre of gravity is. That's in the middle of the object and that's where it will balance. If a body has a regular shape, such as a flat disc or a rectangular sheet of metal, then the centre of mass is always at its geometrical centre. You'll see the letter G represents the centre of gravity or centre of mass of each object, always at the geometrical centre. And then you can also always draw a downwards arrow to indicate that that is where the weight acts on the object. Now, this should say flat triangular shapes. So flat triangular shapes are a little more difficult. In such cases, lines called medians are drawn from the corners of the triangle to the centre of mass. So if you draw a line from each corner to the other side, the point where the lines meet is that object's centre of gravity. It's just another way of working that out. If you have an irregular object, again, the centre of mass is just a little bit harder to find, but you can do that by using this method. A lamina is an irregular object, an irregular shape. It's a body in the form of a flat, thin sheet. The diagrams below show the method for finding the centre of mass of a lamina. It is important to realise that when a body is suspended so that it can swing freely, it will come to rest with its centre of gravity, vertically below the point of suspension. So if you look at this shape, you can put 3 little holes on the shape, just spaced apart. Here you have a pin attached to a cork and a string with a little weight at the bottom. So the stages involved in this method are as follows. Hang an irregularly shaped sheet of cardboard from a pin embedded into a cork. This string with a weight is called a plumb line. Hang a plumb line from the same pin, as you can see. When the cardboard settles, mark the vertical line with the pencil, so draw a line along where the string is. And then when you've got that done, repeat from 2 other points. So now you put B, the hole B in the pin, and draw a line where the string falls along the shape, and then put hole C on the pin and draw another line where the string falls along the shape. The intersection of the vertical lines from the 3 points of suspension will be the centre of gravity. So where those lines meet, that's the centre of gravity for that shape.